I'm going to create a new file in Rhino, and I'm going to create it from large objects in feet. Okay, large objects feet. Click OK, and then I'm going to start Grasshopper from within that. All right, and I created a new canvas for it because the other definition seems to have popped up even though I already saved it. Okay, so what I'd like you guys to do now is I want you guys to put into practice something that you've already learned. I would like you guys to create a variable start point from the x-axis that will put the point off of the grid. Okay? So you guys have already learned how to do that. So I want you guys to create a point that you can move off the grid with 2 number sliders. Okay? You guys have done that like 2 or 3 times so far. So let's go ahead and give that a try. I'll pause the video and then we'll come back to it momentarily. Alright, so I had you guys do that just from memory because I want you guys to be able to start to do stuff on your own. And we have constructed a point and given it 2 coordinate values several times with past things that we've worked on. Okay? So right now, what I'd like you guys to do is we're going to study a new component that we haven't used. So it's under the Vector tab, okay? And it's under Grids. So if you look up Vector tab and Grid, all right, you're going to see that there are several different grids that can be created, and the one that I want you guys to select is a rectangular grid. All right, and I want you guys to drop that onto your canvas, and then I want you to create a sketch of that component and what every one of these things means and what the default value is, both for the inputs and the outputs. Okay? So it's not just a matter of hovering over it and saying, oh, this is asking for a plane. Okay? So it's a matter of saying, it's a matter of writing out what all that stuff is. And I want you to have like a single page sketch of that component. All right? I'll pause the video while you guys do that. Okay, so you've all done that. Okay, so what is the value? What is the value of P on the input side? Look at your notes. Excuse me? What's the default value for P? Not what it says. What's the default value? The world axis, right? Okay. Does the point that you've created have 3 components to it? It's got an X, Y, Z. So see if it'll work. This is one of the confusing things. It's asking for a plane, right? A point isn't a plane, right? But if you'll notice, it's creating its own plane. So really what it wants is a point to put the plane on. So if you feed that point into that plane, it jumps over to it. Okay? All right. So, next, SX, SY. What do you guys think that is? Okay. So, try putting in a number slider to that. Put the number slider in so that it goes from 2 to 10. 2 to 10. Okay, so what does what in my particular case, what's the 2 represent? Anybody want to take a guess? No, it's XY. X Y. So what's it represent? Allison's got it correct. It's 2 feet. Now, you remember me telling you to create a drawing file in Rhino in feet? Okay, one of the things that I want you guys to learn from this is that Grasshopper inherits the units from Rhino. So whatever's active in Rhino at the time, whatever Rhino file is open when you open Grasshopper, those are the units that are going to come in with it. Okay? All right, good. So what does EX and EY mean? So what do you guys think that means? Okay. So I'll tell you what. Why don't you guys create a number slider again? Let's just try using the same number slider. We're just using the same number slider. All right, so guys, after you have inserted the values for the size of the grid and the number of cells in the grid, I want you guys to flip the number for the size of the cells to a negative number and see what happens to the grid. Okay? Because it's really important that you understand that these numbers that are being fed into the grid are in reference to the world coordinate system. So you remember the whole discussion of quadrants back in 8th grade? So there's a positive quadrant, a positive negative, a negative negative, and a negative positive, right? So depending on what numbers feed into SX and SY is what direction the grid's going to go in. So I've put negative operators on each of these. I'm going to go ahead and delete these, and you'll see that it goes back to being in the positive X and Y coordinate grid system. Okay? I have set my value for the extents to 5 and 5. Okay? So I'll go ahead and let you guys do that. Okay, so just to give you an idea of how I structured what I was working on. So this one's pretty obvious. This is the adjustable point that we're starting with. I gave it the size of each cell. So I took these two number sliders and I've grouped them and named them size of each cell. So that's the size in the X and the Y direction, and then the number of cells in each direction. Note that I have this set to 4 and 2, and that I've got the number of cells as 5 in each direction. Okay? So if we wanted to know what this thing is doing, what would we do? What's a good way to figure out what it's doing? We already did. We already did that. But that's the grid component. What's coming out of C and P? How would you discover what's coming out of there? Add a panel. Correct. All right. So go to params, grab a panel, and let's drop 2 panels in there. What the heck? Why not? Right? And let's feed C and P into those areas. All right, and so if you recall, I mentioned to you earlier when we were talking about these wires, right, that when you see a double wire that is broken, right, what you have, when you see a double wire, it's a list. When you see a double wire that's broken into little pieces, you have a tree, and a tree is a list of lists. So if you recall, a single list before was one of these. It had a point, a point, a point, a point, a point, a point, and that was it. Now this one, since it's a grid, has one set of points, another set of points, another set of points, another set of points. So if you scroll down, you'll see that it has a total of 5 things in it. Why is the last number 4? If it has 5, why is the last number 4? Same thing with this one. Why is the last number 5 in this particular case? But why does it get to 4? Well, you always have a start point. So think about it. Imagine if I was standing on this grid of tiles, right? If I take one step forward, that's 1, right? But so then how do I identify where I started from? 0. 0 is the start point, okay? So that's why you got to remember it, and that's common to people that do programming. All right. Okay, so we're going to get rid of the panel that's got the seat coming out of it, all the cells, and we're just going to keep the panel that's got all of the points coming out of it. Okay. So this particular thing is outputting all of the points that are over here. All right. So let's take a look now at a couple of additional things. Okay. So let's say that we want to drop a circle on every one of these points. All right. So what component might we use? Circle. That's right. So circle. So there's my circle component. And what I'm going to do is read my input. So P, right, is the plane, the location of where the circle is going to be. And R is the radius. So I have to hold the shift key down so I can feed this position into that component. And now you can see that I've got one circle on each of the grid locations. Okay? So everywhere there's a point where they start from, it's dropped a circle on there. Note that I can change the size of my cells. So if these circles are now too close together, I can adjust my size to leave some space between them. Okay? And so I've done that. I've gone ahead and just kind of adjusted it. I can also adjust I can put a number slider in for the radius. And so I'm going to go from 1 less than 5. And we'll feed that in and see what we get. One of the things that should become kind of evident to you right now is that Grasshopper is doing a large amount of data processing and creation, right, as we do this. So most of the stuff we've done so far, it would take you much less time to do in Rhino than it would take you to do in Grasshopper, right? Defining the sphere, putting it at an adjustable location from the center of the sun, making it rotate around. You couldn't animate it like that, but you could draw and create the sphere and do all of that stuff in Rhino much faster than the time it's taken us to do in Grasshopper. But think about Grasshopper in this fashion. What if I said, hey, you know what, we have a client, and the client's looking for this layout of circles, and I want you to do, 30 different schemes with different radiuses of circles and different grid sizes and patterns. Well, you can see that just by moving a couple of sliders around, you could generate many, 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 many different schemes very quickly. So this is sort of where the power of or one of the places that the power of the program becomes evident. Okay? So next thing I want to do is I want to show you a different component, and I think it's called points. I'm going to go to display. So see where it says display right here? And then come down to vector and point list. Drop that there. Read the two inputs. What are the two inputs? Size and points. All right? So we'll grab this points list, feed it into points, and if you zoom in over here, you'll see that there's now a number on each of the intersections. If we want to, we can put a size to that. So I'll grab this number slider, copy it, and feed that into the size. And that'll allow us to change the size of the numbers. Okay? All right, so once again, I want you to break apart what each of these sub areas is doing. You don't have to worry about the panel so much, but I want you to break apart what points does, and I want you to break apart what the circle is doing and what this slider component is doing. So I'll pause the video and let you guys do that. Alright, so I'm going to pull this back over and just kind of give you an idea of what I've done to kind of organize all of these outlying components, or all of these outlying groupings of components in mind. So I said one of them down here is a circle, so place an adjustable circle at each intersection. Right up here, this sets a number with an adjustable size at each of the intersections. But here's a question. What if I want to feed different sizes of circles into this thing? different sizes of circles into it. So like for example, let's just say that I take my radius slider here and I delete it. And instead of a radius slider, let's say I feed it with a panel. Alright, so here's a panel. And I'm going to put a number in the panel of 1.5. Okay? So if I feed that into the radius, I get circles that are 1.5, and they're all 1.5. They're all the same, correct? Yes. All right, so watch what happens if I try to add another value. So say I press enter and type in 0.75. If I click OK, something's going to happen. Right? First of all, the circles all disappeared, and my circle function went into error. Right? The circle function went into error because as soon as I typed in multiple lines of text inside of a panel, it assumed that what I'm typing is text, not numbers. Okay? So you can take a panel and make it to where it overrides that and accepts it as numbers. So let me show you how that works. So if you right-click the panel and you go up here to where it says multi-line data, notice that it's turned on. Turn it off. Now, doesn't this look a bit like this list up here? Notice that it is a double line. So what that's telling you is that that panel is now feeding a list into the circle component. So now if I was to go in there again and I was to type in 2 or 1, then 2, then 3, you would notice that it's sequentially feeding, right, those sizes into the numbers. Notice how it's doing it. Notice that the 0 value is getting all 1.5 unit circles. Right? So here's the zeros. All of the 1s are getting the little circle at 0.75. Right? The 2s are all getting the 1. The 3's getting the 2, and the 4's getting the 3 unit. Okay? So understand how this list, right, is feeding into the circle component, which is receiving a tree. All right? So what you guys got to understand is that this 0, 1, 2, 3, 4 corresponds to one of these rows. But since it's producing a tree, right, because we have an x and a y direction, right, that it's one tree or one list, list 2, list 3, list 4, list 5, list 6. Okay? And if you scroll down here and you count, it should come up with a total of 6 lists. This tree has 6 lists in it. Okay? So I'll pause that and let you guys kind of do the same.